channel Knowledge of, and subscribe to our channel and click the bell icon for the latest update. Today we're going to start with your CBNST class, that has been the computer based numerical and statistical technique. This has been the classes, your 24th classes, which we have to discuss here. And in 24th classes, that is, we had done your 23rd classes in the last session, where we had completed your unit 1 as well. And in that has been the name of the unit we have here is computer arithmetic errors and rules of equation, that we had done. Even though in this class, if I'm going ahead here in the detail, that being the new the second unit we had named as is interpolations and your curve fitting, that we have to cover up, where we'll discuss the important points to remember for that: Lagrangian interpolations, Newton dividing differences, interpolation method, finite difference operator, linear regressions, fitting of straight lines, polynomial regressions, fitting of second degree that is in the parabola, linearizations of nonlinear relationships, and interpolating with cubic spline. With their same, we'll discuss about it. But before starting with this, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and even though you can also enjoy the video as well. So here we go ahead. First we'll go ahead for the formulas that we have to discuss here, which has been important one, of course. So Lagrangian interpolations formula, that is, we'll discuss first. Lagrangian interpolation formula. Okay, for that we have to discuss here first, which has been your y equals to xr minus x1 xr minus x2 till xr minus xn upon x0 minus x1 x0 minus x2 till x0 minus xn y0 plus xr minus x0 xr minus x2 till xr minus xn upon x1 minus x0 x1 minus x2 till x1 minus xn. This is for y1, which is write it on here. It will be multiplied plus xr minus x0 xr minus x1 and xr minus x3 till xr minus xn multiplied by y2 whole upon x2 minus x0 x2 minus x1 and x2 minus x3 till xr x2 minus xn plus that has been xr minus x0 xr minus x1 till xr minus xn minus 1 whole upon that has been x0 xn minus x0 xn minus x1 till xn minus xn minus 1 multiplied by yn. That we have for the Lagrangian interpolations formula, which we'll use when we are going to solve it out for these type of a question. Now we go ahead with another formula, that has been for truncation error in Lagrangian interpolation. So truncation error in Lagrangian interpolation we have to discuss here. The formula we have for the same: 0 en equals to fx minus phi n phi pi x minus xr minus x0 xr minus x1 xr minus xn whole upon n plus 1 f n plus 1 z. This has been the formula here. Now we discuss about the Newton's divide and differences interpolation. Newton's divided differences interpolation. So for the same we go ahead. yr is equals to y0 plus xr minus x0 y x1 x0 plus xr minus x0 xr minus x1 y x2 x1 x0 plus xr minus x0 xr minus x1 xr minus x2 y x3 x2 x1 x0 plus xr minus x0 xr minus x1 xr minus xn minus 1 y xn xn minus 1 x0. Now we go ahead for the next: truncation error and Newton divide and differences interpolation. For that it will be x1 n plus 1 z. Now we go ahead for the question that we have to discuss here, and that is being find the interpolating polynomial using the Lagrange formula and Newton divide and differences formula for the following data here, and hence you have to show both the methods give a same polynomial. We go ahead for the question here. Find the interpolating polynomial using Lagrange's formula. Second, Newton's divided difference formula for the following data that we have. This is for 1, 2, 3, 5, 0, 7, 26, 124. Hence, show that both the methods give same polynomial. So we solve for the same. Here x0 is equals to 1, x1 equals to 2, x2 equals to 3, x3 is equals to 5, and y0 is equals to 0, y1 is equals to your 7, and y2 is equals to 26, and y3 is equals to 124. Okay, that has been given. So we'll do, and we'll use the Lagrange formula for the same. That we had discussed here in the starting class. So consider the Lagrange interpolation formula first, then we'll put the values for that. The formula we have here, yr equals to xr minus x1, xr minus x2, xr minus x3 upon x0 minus x1, x0 minus x2, x0 minus x3, y0 plus xr minus x0, xr minus x2, xr minus x3 whole upon, it will be x1 minus x0, x1 minus x2, and x1 minus x3. Then y1 plus xr minus x0, xr minus x1, xr minus x3 upon x2 minus x0, x2 minus x1, x2 minus x3, y2 plus xr minus x0, xr minus x1, and xr minus x2 whole upon x3 minus x0, x3 minus x1, and x3 minus x2, y3. So we'll put the value for the same. Yr equals to xr minus 2, xr minus 3, and xr minus 5 upon 1 minus 2, 1 minus 3, 1 minus 5 multiplied by 0 plus xr minus 1, xr minus 3, and xr minus 5 whole upon 2 minus 1, 2 minus 3, and 2 minus 5 into 7 plus xr minus 1, xr minus 2, and xr minus 5 whole upon 3 minus 1 upon 3 minus 2 and 3 minus 5 into 26 plus xr minus 1, xr minus 2, and xr minus 3 whole upon 5 minus 1, 5 minus 2, and 5 minus 3 into 124, and that will give you the value here as xr cube minus 1. Now use replacing xr by x we get the polynomial. So that will be having as your y equals to fx, and that is being fx equals to x cube minus 1. Now we'll use the another formula, which is being the divided differences formula, and which is also being important one that we have to discuss here. We'll make a table for it and we'll solve the further as well. So we'll use the formula as divided difference formula. So for the same, we'll make a table for it. X, y, by xn minus 1, y xn minus 1, xn minus 2, y xn minus 1, xn minus 2, xn minus 3. So for that, made a table. We'll draw the table here. For x0 is equals to 1, then y0 equals to 0, and for here it is being y x1, x0 is equals to 7, and x1 equals to 2 and y1 equals to 7, then y x2, y x1, x0 equals to 6. For the another one, y x2, x1 equals to 19, and y x3, x2, x1, x0 is equals to 1. When x2 is equals to 3, then y2 is equals to 26, which will give you y x3, x2, x1 equals to 10, and y x3, x2 equals to 49, and when x3 equals to 5 and y3 equals to 124, that we get here from the table. Now we divide using the divided differences formula, that has been the important one and which we have to discuss here as follows as well. So we go ahead for the same. We'll use the formula and then we'll implement it. That divided differences formula. So for the same, it will be yr equals to y0 plus xr minus x0, y x1 x0 plus xr minus x0, xr minus x1, y x2 x1 x0 plus xr minus x0, xr minus x1, xr minus x2, y x3 x2 x1 x0 plus that we have your formula that we have. Now we'll be putting the values for the same, and that will implement it, and that is being equals to yr equals to 0 plus xr minus 1 multiply 7 plus xr minus 1 xr minus 2 into 6 plus xr minus 1 xr minus 2 and xr minus 3 into 1, which is equals to xr cube minus 1. that has been the formula. We'll have put it the value for the same, and that what we'll have to go ahead. So further when we'll go ahead here, that has been add xr equals to x, yr equals to y, which is equals to fx, hence fx equals to x cube minus 1. This is the required polynomial using the divided differences formula. You have to note that here this is the required that both the methods give rise to the same polynomial, which has been of course the important one here. So we go ahead for the next one, and that has been the another next question here, which is we have to discuss here with the data that has been given. The question is, for the following data, find under root 1.1 using Lagrange's interpolation. Determine the accuracy of interpolation. The data we have x under root x, it is 1, this is 1, 1.2, 1.095, 1.3, 1.140, and 1.4, 1.183 that we have. So we'll go ahead for the solution here, that has been the important one. So here x0 is equals to 1, x1 equals to 1.2, x2 equals to 1.3, and x3 is equals to 1.4, where y0 is equals to 1, y1 equals to 1.095, y2 is equals to 1.140, and y3 is equals to 1.183, xr equals to 1.1. From the Lagrangian formula that we have here and that we had implemented, I will do that. Yr equals to xr minus x1, xr minus x2, and xr minus x3 whole upon x0 minus x1, x0 minus x2, and x0 minus x3, y0 plus xr minus x0, xr minus x2, and xr minus x3 whole upon x1 minus x0, x1 minus x2, and x1 minus x3, y1 plus xr minus x0, xr minus x1, and xr minus x3 whole upon x2 minus x0, x2 minus x1, and x2 minus x3 multiplied by y2 plus xr minus x0, xr minus x1, and xr minus x2. This has been the y3 here, that has been x3 minus x0, x3 minus x1, and x3 minus x2. We'll putting the values for x and y, we get yr equals to x1.1 minus 1.2, 1.1 minus 1.3, and 1.1 minus 1.4 whole upon 1 minus 1.2, 1 minus 1.3, and 1 minus 1.4 into 1 plus 1.1 minus 1, 1.1 minus 1.3, 1.1 minus 1.4, which is into 1.095 whole upon 1.2 minus 1, 1.2 minus 1.3, and 1.2 minus 1.4 plus 1.1 minus 1, 1.1 minus 1.2, 1.1 minus 1.4 whole upon 1.3 minus 1, 1.2, 3 minus 1.2, 1.2 1.3 minus 1.4 into 1.140 plus 1.1 minus 1, 1.1 minus 1.2 and 1.1 minus 1.3 whole upon 1.4 minus 1, 1.4 minus 1.2 and 1.4 minus 1.3. That has been multiplied by 1.183. It will give you the value 0.25 plus 1.6425 minus 1.14 plus 0.2958 equals to 1.0483. Under root 1.1 equals to 1.0483. Actual value of under root 1.1 is 1.0483. The error in interpolation, we go ahead. Error in interpolation equals to 1.0488 minus 1.0483, which is give you 0.0005 that we get as an answer. And now we're going to end up with this as well, and that will discuss here in the next coming class with the new or that we have to discuss here. So in terms of it, if I'm going ahead, so first of all, it's a huge request to all the viewers to please go ahead with like, share and subscribe our channel, so that many and maximum people can get the information at once, and you can also enjoy the video as well. Other than CBNST, we had done your sociology and software engineering, we had done your chemistry for class 12, that has been, and for class 11th as well, that is for unit 1, unit 2, unit 3, unit 4, unit 5, unit 6, unit 7, unit 8, unit 9. And with the conversions and logarithm, we are dealing with ER diagram, we are dealing with English vocabulary, we had done your quantitative aptitude, we are dealing with, in that we had started with arithmetical ability, in that we had done operations on numbers, the STF and LCF of numbers, decimal fraction, simplification, square roots and cube roots, problems on numbers, problems on HSRs and indices, percentage and profit and loss we are dealing, which has been the 11th topic. In terms of reasoning, we had done your verbal reasoning, in that we had done general and elaborate in the logic reasoning. In non-verbal reasoning, we had done series analogy, classification, analytical reasoning, mirror image, water image, embedded figure, completions of incomplete pattern, figure formation analysis, and practice question set. In terms of computer-based numerical and statistical technique of this unit, is this chapter that has been unit 1 we had completed, that has been the computer arithmetic errors and rules of equation. Here we had done floating point arithmetic, machine abscon, and a round of errors, chopping error, truncation error, associative and distributive law of the floating point arithmetic, inherent error, error propagation, numerical instability. In roots of equation, we had done second method, Newton-Raphson method, and fixed point iteration method for simple roots and derivations of the rate of the conversion, static and accelerations of the conversions, modified Newton-Raphson method for the multiple roots, Birch-White method for the polynomial, Weierstrass method for the quadratic factor, and computer algorithm of these methods as well. In terms of unit 2, we have to cover up the interpolations and curve fitting, where we had to cover up the algorithm and the error analysis of the Lagrange and the Newton divided differences, interpolation, relationship in the various differences operator, piecewise linear interpolation, cubic spline interpolation, naturalist spline, Chebyshev's polynomial approximation, Len-Cos economization of the power series. In curve fitting, we have to cover up the linear and nonlinear least squares approximation, conditional in the least square method, Gram-Schmidt's process of orthogonalization, computer algorithm of least square curve fitting. In unit 3rd, we have to cover up the differentiation and integration. In that, we have to cover the method based on the interpolations and the finite differences, Richardson extrapolation. In integration, we have to cover up the error analysis and trapezoidal Simpson method, Newton Accords integration method, the Gaussian integration method, Gauss-Lagrange method, Lobato integration method, Radau integration method, error terms and pertaining the integration method. In unit 4, we have to cover up the solution of simultaneous linear algebraic equation, where we have to cover up the Gauss elimination method, a third conditional system, conditional number, successive over relaxation method, rate of the convergence, solutions of ordinary differential equation. We have to cover the single step method, Runge-Kutta second order, third order and fourth order, multiple step method, predicated and corrective method. In statistical technique, we have to cover the statistical hypothesis, test of hypothesis, type 1 and type 2 error, level of significance test involving the normal distribution as well. So here we're going to end up with, it's a huge request to all the viewers to please go ahead with like, share and subscribe to our channel, so that many and maximum people can get the information at once, and even you can also enjoy the video as well. Thank you. Hope you enjoy this video. If you like this video, please give a thumbs up and give a suggestion on the comment box. Thank you.